Hello everyone and welcome back. So now we're going to talk about how you can design against fracture. Okay, designing against fracturing. So how does that work? Well, we talked about our fracture toughness last time. And it's right here. So this is our fracture toughness. We had some parameters here. This one right here is just usually going to be about 1. This is that critical stress where fracture is going to begin. This is the length of the crack. This is pi, coming from various things. And so if we are down here at the bottom, we won't have fracture. So as the crack length grows, if we stay down here, as long as we're below this line, we're fine. It's not going to fracture. Now eventually this fracture line will get so low there's nothing we can do anymore and it will cause it to fracture. But for now, we're good. We still have this kind of brief, beautiful moment in time where it's good. So if we have material and we want it to be usable, we have to make sure that we are always below this critical stress. If we're not, everything's going to go wrong. Always below that critical stress. Now, another way you could think about it is to say, okay, well, rather than aiming for the critical stress, if I have a given stress, I can say, what is an allowable crack length? If I need to be stressed up to this point, this is not really giving me the right, yes. If I have to have a stress all the way up to here, well, then my crack length can only be so long. Otherwise, it's going to fail. Both of these are used. If you think about airplanes, it might be that they know exactly what stress it's going to be under for a given time. They know exactly what stresses it's going to be under for most flights. And so from that, they're going to be looking and saying, okay, are there any cracks that are this length or are going to be able to get to this length during this flight? Now, there's always a factor of safety. So normally they're saying divide by 2 or by 3. They're making sure that they're nowhere close to that critical crack length. Because you do not want to be like, oh, well, we were just slightly off in our calculations and everyone died. No, that's not good. You can't have that. So either one of these two can be used. Okay? Either one of these two can be used. So let's look at a design example here for an aircraft wing. So we have an aircraft component, and it's made from material that has a fracture toughness of 20 megapascals per meter to square root. It has been determined that fracture results at a stress of 112 megapascals, that's our critical stress, when the maximum critical internal crack length is 9 millimeters. For the same component and alloy, compute the stress level at which fracture will occur for a critical internal crack length of 4 millimeters. Okay, so how are we doing this? Why are we calculating this? Well, the big thing we're going to have to do here is we're going to need to figure out what y is. Now, I said it's around 1, and if you aren't given it and there's nothing else to do, then you can just say 1. But in this case, we had enough information that we can take our fracture toughness equation and we can solve for y. Because that parameter is going to be the same for both, depending on what, that parameter won't change. For a given alloy, a given situation, a given component, that parameter is not going to change. And so we plug everything we have in here, being very careful that we have our correct units. Okay, so this is meters. That means that this needs to turn to meters as well. This is megapascals. This needs to be in megapascals as well. Make sure you have the right units. That's the biggest mistake. And you'll solve for it and get 1.38. Now all we have to do is, now that we know that, we plug in and we just change that number to a 4. So what's our critical stress? Well, we solve and we see, yes, our critical stress, after plugging everything in, all we have changed is we've now solved for stress instead of our parameter. We plugged in our parameter that we just solved for. We plugged in the new crack length, and we get our critical stress for 4 millimeters would be 168 megapascals. So it can take more stress when it has a shorter crack length. More stress when it has a shorter crack length. Well, that's it for this time. Hope this helps you, and I'll see you all later. Have a wonderful day. Bye-bye.